In this video, we are going to try some more complex multi-step conversions using dimensional analysis. And I find that in these problems, probably the most challenging part is dissecting the problem and identifying what is in there. Where are all of these conversions? What is it actually asking me to do? Once you've identified that, then it's really just more of the same. You're going to connect units to each other to get where you need to go. So it can be a little bit intimidating, but we'll start by just reading the problem and finding the keywords in there. This one says you need to administer 25 milligrams per kilogram of ampicillin to a child that weighs 67 pounds. If the stock on hand is 250 milligrams per tablet, how many tablets should be given to the child? The first thing I'm going to do is identify what is given and what we are trying to find. Now, there's a lot of information here that is given to us. And when I say given, I mean I'm looking for a number and a unit that is off by itself. It's not part of a conversion factor. So notice that this one, it has that slash, which really means per. Anytime I see per or any kind of slash or anything that looks like a dosage, that's a conversion. Right? So that's not what I'm going to start with necessarily. I'm looking for a number that is just off by itself. And that would be the 67 pounds. That's just kind of hanging out there. It's not involved in a conversion immediately. So that's my given. I know that the patient weighs 67 pounds. Now, what we're looking for tends to be a little bit easier to find because it's saying how many, right? So that is framed in terms of a question. And what it's asking us to find is the number of tablets that need to be given to the patient. Everything else in here is a conversion of some form. So here I see a number that has that per or the slash. That's saying that in 1 kilogram of body mass, or a kilogram of the patient, or why don't we say a kilogram of child, since this patient is a child. For every kilogram of their body mass, they need 25 milligrams of ampicillin. So that's a conversion, right? If we need 25 milligrams per kilogram, that's a conversion. And anytime you see that, you can turn that into a conversion factor. So we could put kilograms on top, and then milligrams of the medication in the denominator. Or we could flip that upside down, like for any conversion. Okay, one down. There is another one here that's saying that there are 250 milligrams of medication per tablet. So that really means that in 1 tablet, we have 250 milligrams of ampicillin. And we can turn that into a conversion factor, much like we did with the previous one. So there are 250 milligrams of ampicillin per tablet. So I could put 1 tablet in the denominator, or I could flip that upside down. All right, now we have everything we need written out, or at least everything that's given to us in the problem, and we can go ahead and do that conversion. I'm always going to start with what is given and what's just kind of off by itself. So I'm going to start with the 67 pounds, and that is the weight of the patient, which is a child. So we have 67 pounds, and ultimately we're trying to get to the number of tablets. So I'm not interested in pounds here. I want to get rid of that. Now we do have a bit of a problem because it looks like in order to get to the number of tablets, we need the milligrams of ampicillin. And maybe we should actually construct a roadmap here. So I will leave myself some room. Okay, roadmap. We are starting with pounds. we're trying to end with the number of tablets. And we definitely have no way of doing that directly. But we do see that there is a conversion that connects the number of tablets to the milligrams of ampicillin. So I could use the milligrams of ampicillin to ultimately get to the number of tablets. Okay, but I don't have a direct relationship between pounds and the milligrams of ampicillin, so there's something we have to do in between. And I do see that there is a connection between the milligrams of ampicillin and the kilograms of the child. So we can use that conversion to ultimately get to milligrams of ampicillin, which will get us to the number of tablets. Fine. But we are given pounds in the beginning, and we need to have some way of getting from pounds to kilograms. So that is a piece that we are missing here that is not given to us in the problem, but that's something that you could look up in a reference table or in the textbook. Okay, so we need a conversion between pounds and kilograms here. And that will be that 1 kilogram is equal to 2.2046 pounds. And just like any other equality, you can turn that into a conversion factor. You could put the kilograms in the numerator and the pounds in the denominator, or you could turn that upside down and put the pounds in the numerator and the kilograms in the denominator. Okay, so that took care of that missing component. So we have pounds here. We want to get rid of that. We're not interested in pounds, so pounds will have to go in the denominator, which means this is the conversion factor that I want. That's the only one that connects pounds in some way. And it puts pounds in the denominator. So 2.2046 pounds will go in the denominator, and the kilograms will go in the numerator. And now I see that the pounds cancel out because they are diagonal from each other. We're left in kilograms of the child. Okay, but we're not interested in the kilograms of the child. We want to know how many tablets we need to give them. So looking at the rest of our information here, we do have a connection between kilograms of the patient and the milligrams of ampicillin that we need to give them. And since the kilograms here are in the numerator, in order to cancel that, kilograms will have to go in the denominator. And of these two conversion factors that connect kilograms to milligrams, this is the one that contains kilograms in the denominator. So that's what we're going to use, and then we're going to put the milligrams of ampicillin in the numerator. Okay, and we see that in 1 kilogram, so for every 1 kilogram of this child's body mass, we need to give them 25 milligrams of ampicillin. And now the kilograms cancel out, and we're looking at 25 milligrams of ampicillin. But finally, we don't really care how many milligrams of ampicillin specifically. We're interested in the number of tablets. So how many tablets do we need to give them to administer those 25 milligrams of ampicillin? And since here 25 milligrams of ampicillin are in the numerator, the milligrams of ampicillin will have to go in the denominator. And the connection between tablets and milligrams is that in every 1 tablet, there are 250 milligrams of ampicillin. Since we want milligrams in the denominator, this is the conversion factor we're going to use, the one that puts milligrams in the denominator and the number of tablets in the numerator. And finally, the milligrams of ampicillin cancel out, and we're looking at the number of tablets. So notice that every unit canceled except the one that we're looking for, which is left at the end in the numerator. And now I'm going to plug everything in and calculate that final value. So we are multiplying everything in the numerator and dividing by everything in the denominator. So that's going to be 65 times 25. I'm ignoring the ones here because they're not going to change anything. And then I'm dividing by 2.2046 and 250. And I'm getting 3 tablets will be needed to administer that dose. All right, check out the next video for a second example of